Let's consider the topic simple AC circuits. Now, I would like you to watch this video to the end because I am going to be telling you exactly all the things that the examiner expected to know in terms of simple AC circuits. Now, this topic is one of the topics that students find challenging or find difficult. But in this lesson, I'm going to be breaking them down so that you will understand and solve any question that comes up in simple AC circuits. If you are new to this channel, please kindly subscribe. Now, without wasting most of your time, let's get started. Now, the first thing that we need to talk about is, first of all, what is AC? That word AC, that simply means, the word AC simply means what? It means what? Alternating what? Currents. So the word AC means what? Alternating currents. And what is alternating current? Alternating current is that current that changes periodically or occasionally. So I can just say that alternating current is current that does what now? Changes periodically. I can also say that it changes what? Occasionally. It changes what? Occasionally. Okay, it changes periodically or it changes what? Occasionally. And that is what we mean by what we call what? Alternating current. Now, this current, what happens to this current now? This current becomes positive at a particular time, and at another time it becomes negative. So you can also just classify this that alternating currents are current that what? Varies. Okay, current that varies what? Okay, let's just say current that does what? That varies with time. So that current that varies with time is what you call alternating current. Whereas direct current, you can call direct current what? Steady current. It does not vary, just call it your steady current. So the difference between both of them is that alternating current is current that varies with time, whereas direct current is current that is what? Is your steady current. Both of them has the same unit, and the SI unit for current is still remains what? Ampere. Now, you cannot have alternating currents without having something that will produce it now. So alternating current is being produced by what we call alternating voltage. So alternating current is produced by what we call alternating current. Alternating current is produced by what we call alternating what? Voltage. If I do not call it voltage, I can also call it what? Potential difference. And I can represent this with letter V. Whereas my alternating current still remains your letter I. I can use my letter I to represent that now. Alright. Now, these are the basic things that you need to know about this now. Now, before I proceed to talk about the features of alternating current now, let me show you how we represent, or let me start with the symbol of alternating currents. Now, the symbol of alternating currents is what? It is represented as what? It is represented in a waveform like this now. But at the same time, graphically, how do we represent it graphically? You know, in terms of graphical representation of alternating currents, graphical representation. Okay, let's talk about the graphical representation. How to represent it graphically? In terms of graphically, we represent alternating current using what we call the sine graph. We have so many graphs. We have the square wave graph. We have the sawtooth wave graph. So, but we're going to use the sine wave graph. So we are going to use the sine graph. And so we represent that using our sine graph. This is our sine graph. Now, whenever you're plotting it, because we say that it varies, it changes, you will discover that if here is 0, here is going to be positive, and here is going to be negative. You discover that it was positive at a particular time and now became negative at another time. Remember, here is going to be your time. You are plotting it against your time. So this axis could be what? Your voltage or your what? Your current, any of that. Now, another thing that your examiner is expected to know is that since you are now aware that alternating current uses what you call a sine graph, they are expecting you to know what you call the maximum or peak value You are expected to know how to locate or where to locate your maximum or peak value. Now remember that when you did your wave, you remember that this place, from this rest position to this highest point, from this rest position to this highest point in your wave, it is called amplitude. But in terms of alternating current, this place is called maximum or peak value. So this line or this point is called your maximum. It is called maximum or peak value. Please, I would like you to be taking note of all this. Is very simple. These are the information that if you have it, any question that is given to you in alternating current circuit, you answer them with what we like, with ease. Now, since I've called this place, I can also call this point from here to here. I can also call it the same thing. I can call this line what you call maximum or peak value. That is from here to here, maximum or peak value. And this maximum or peak value are always represented by a subscript of 0 or m. Now, okay, what I mean is this now. Now, for current, assuming it is current here, I'll write IO. I'll assume it is voltage, I'll write VO. Then the same thing here, if it is I, I'll write IO. If it is VO, if it is V, I'll write VO there. Now I'm going to dive into this thing very well properly with time, and when you go into it properly, we're going to talk about it more. But for now, just bear this in mind. Now, before I talk about other things the examiners are expected to know in AC, let's talk about what we call the features of alternating current. Now let's look at what you call the features of alternating currents. Number one, you can say that it changes with time. It is a current that varies with time. It varies with time. Please, this comment that I say it varies with time is still the same thing. Somebody say it changes with time or it changes occasionally. It's still the same thing. So it varies with time. That is number one. Number two is that it has no polarity. It has no polarity. So alternating current has no polarity. Unlike your direct current has polarity, the positive and the negative pole. But for alternating current, it has no polarity. That is, it has no positive or negative pole or terminal. It has none of this now. Then another feature of alternating current that you are expected to know is that it has frequency. Alternating current has what we call frequency. Then another feature is this now. Alternating current, in terms of transmission, alternating current is preferred over direct current. Why? Because you can transmit alternating current over a long distance at high voltage and low current, and power loss that we're going to have here is going to be what? Minimal. So it can easily be transmitted over a long distance with what? With minimal power loss. With minimal power loss. So this is another feature alternating current has. So this is it now. Now, since I've talked about what you call the features of alternating current now, let's go about the main thing that we have for this now, which is what you call the alternating current circuit. Now we have what you call the alternating current circuits now. And what is alternating current circuit? Alternating current circuits. Okay, that's number one. Alternating current circuit is a circuit with varying alternating current or voltage. It is a circuit with what? Varying currents or voltage. So that is it. Then another one is that alternating current circuit is a circuit with what? Peak value. It has peak, root mean square, and instantaneous Instantaneous. Okay, let's put this in here. Instantaneous what value. So whenever we are talking about alternating current circuits now, it just simply means that alternating current circuit has what you call peak value. It has what you call the root mean square value. The circuit also have what you call the instantaneous value. Then it also has what you call reactance in place of what you call resistance. You know, in direct currents, we call this resistance in terms of direct current, but in alternating current, the opposition caused by the component is mostly called reactance now. Okay, so now your examiner or the examiner is expected to know this peak value, how to calculate peak value, how to calculate the RMS value, how to calculate the instantaneous value. But before then, remember I told you that alternating current has what you call what now? Frequency. Now this is what I'm going to do now. I am going to be, in terms of this alternating current circuit now, I am going to start from the beginning. I'm going to show you each of the things you expected to know one after the other. Keep watching this video and keep listening, because you're going to get every details that you need to know in alternating current circuit. And by the time I end this class ends, you'll be able to solve these questions very well. Let's consider the first one, known as the frequency in AC. The examiner you are expected to know what we call frequency in AC. You know, the frequency that we have alternating current in Nigeria is always a 50 Hz. In some countries, the frequency is 60 Hz. That is, the frequency in Nigeria is about 50 Hz, whereas in some countries it is what, 60 Hz. But let's continue with this now. Now, they will ask you question under this. You are expected to calculate your frequency. Let's consider one question under frequency in ACs, because let's start from there. You learn frequency. I will not talk about other things that you need to know how to solve in alternating current circuits. Let's consider this question. Now, this question says an alternating voltage. You know, we're talking about alternating current and alternating voltage, because we cannot talk about current without voltage. Now, the question says an alternating voltage with a frequency of 50 Hz. Our frequency is how many? Frequency is how many? 50 Hz. Has a period. You are expected to calculate your period. And how we calculate your period? I will just say my period is, that is, I will say frequency is equals 1 over what? Period. You recall that. Then I can interchange this, which means that my period is equals 1 over f. I place this, remove this and put this one here. So I have it as 1 over f. Cool. So which is equal to 1 over, what is my frequency? This is my 50. So which is equals 1 divided by 50 is going to give me what now? 0.02 seconds. And that is my option what? My option A. Very simple question. Now, you have learned about what we call frequency in AC or alternating current. Now, the next thing that you're expected to know in AC is what we call the peak and instantaneous value. Now, if I do not call this peak, I can also call it what you call it maximum. So I can call this peak, or I can also call it what? Maximum what? Value. Now, this peak or maximum value, we normally represent using a subscript of what? 0, or that of what? M to the letter that we have. So which means that we have peak value, we have what we call peak currents, we have what we call peak currents, and peak current is represented as what? I naught, or sometimes you can have it as IM. So this is your peak value, or sorry, this is your peak currents. Then we also have what we call peak. It's either I call it peak. Remember, you can also use the word maximum. Peak or maximum. You can also use maximum. Peak or maximum voltage. Remember that if you do not call it voltage, you can also call it PD, potential difference. So that one can be represented as VO or as what? VM. But the most common one is this. You always see it with what? VO. Now, since I've already talked about what you call this peak value now, the next thing you need to know is what you call instantaneous value. Now, there are questions that you will see. This question will contain your peak value and instantaneous value, and that is what I want us to be talking about in this section. For instantaneous value, your instantaneous value is given as what? Our instantaneous value is given as, is equal to what you call your peak value. Please take note of all this that I'm saying. If this is your first time of hearing this, just write them down. The more you write them down, the more you're going to record them. Times your sine theta. Now let me explain each of them. That your theta that you saw over there is known as your what? The theta is known as your what? Your phase angle. It's known as your phase angle. So that one is called your phase angle. So in actual sense, I'm supposed to say sine phase angle there, but since I've already written theta, it's also known as your phase angle. And the unit of our phase angle is always measured in degree, which is the most common, or in radian. Sometimes your examiner will give you the question in radian. So your radian are always represented as what? Okay, pi rad. You always see the word rad or degree this way, depending on the question that was given to you. Now, since I've already stated this clear, since you've already stated this, that the instantaneous value is equal to your peak value times your sine theta. So what is going to be your instantaneous current? Your instantaneous current, because instantaneous current will be equal your peak current times your sine phase angle. And if we do that of voltage, it's going to be instantaneous voltage is going to be what? Peak voltage times your sine theta. Now let's consider a particular question. Now consider the first question. The first question says calculate the maximum current. Maximum current, remember the formula for maximum current or the symbol for maximum current, which is your I naught, which is I naught, given that I is equals 3 sine 60 degree. So what is going to be my maximum current now? Remember the formula. So I gave you the formula as I is equals to I naught sine theta. So it just simply means that if I compare this, let me put this here, I naught sine theta. If I compare this, this will be to this to this, this to this, and this to this. So what is going to be my I naught? So since my instantaneous and instantaneous, my I naught or my peak current, sorry, this is my peak current, is going to be what? Is going to be 3 ampere. That's all, because I have it here. Sine theta. My phase angle is already 60 degree. And that is for that question. Now coming over to the second question. The second question says what? In an AC circuit, the peak value, okay, of the PD, which is peak value, which is VO, I'll write VO, is equals how many? 180 volt. That's 0.1 I need to take note of. Then I'll say, what is the instantaneous PD? Instantaneous PD, which is V. I am looking for instantaneous PD. Okay. When phase angle, and what do I use to represent my phase angle, which is theta, 45 degree. So since I am looking for that now, what formula do you think I'm going to use? Remember that when I started this section, I told you that we are learning peak and instantaneous value. So the formula that has to do with that is going to be what? V is equals VO sine theta, because this formula is used to find three things, which is instantaneous voltage, peak voltage, and phase angle, and which are what we have here now. So let's switch the value. I have it as V is equals, what is my peak value? I will say 180 times sine, what is my phase angle, which is what? 45. And since I'm not making use of calculator, so sine 45 as a special angle, what do you have here now? I'm going to have it as V is equals 180 times what? So 2 over 2. Special angle now. Now when you know this do this over 1. When you cancel this, what do you have now? 90 sort 2 volts. And that is your answer. The correct option is what? C. And this is still the same. This is another JAMB question. So you see that the questions they will ask you are not difficult. They are very simple. The only thing you need to know is that read the question and know exactly what to do. This question, when we read this question, the question says peak value and instantaneous value. And the formula that connects instantaneous value and peak value is this kind of formula that I've given out here. So in summary with the first one that we did, you should bear it in mind that I told you that we have I is equals IO sine theta, and we also have V is equals VO sine theta. So this I is equals to IO sine theta is used to calculate your I, your IO, and your phase angle. Likewise, your V, VO, and your phase angle. Some textbook, or sometimes you might not see this V, they might use something like EMF. It's still the same thing. So which means you're looking for your E, your EO, and your phase angle. Now, since we are aware of this now, this is not the only thing that we calculate for the instantaneous. This is not the only thing we calculate. What if the instantaneous question, or the process of asking you the question contains frequency? What if the question contains period? How will you solve it? Because most of the questions that you're going to see under instantaneous, it's either it has phase angle, or it has or they ask phase angle, or it has frequency or they ask frequency, or it has period or they ask you period. These are the three things that we normally see under instantaneous value. Apart from the one that has your peak value and your phase angle, the one that has phase angle, this is not the only formula for instantaneous value, whether that of current or that of the voltage. Now let's consider the one that has a frequency. Let me show you the one that has frequency. I'm going to derive that now, and the one that has period. Now, since we all know that I is equals IO sine theta, that is, we've gotten this, we've known about this. This is the first one that we did. We know this one already. Now, we can also recall that my theta is equals omega t. Okay? So since theta is equals to omega t, this is the first one that we have. We've done this one. So I can now substitute to have I is equals IO sine omega t. I don't need this one yet. So I can also recall that my omega, which is my angular frequency, is equals 2 pi f. So for that reason, I can just say that I is equals IO sine 2 pi ft. Please, how did I get that? This is my I, this is my IO. This remains my sine, this is my sine. But this omega, I replace this omega with 2 pi f. That's I have 2 pi f, and I brought down this my t. So this is the second one I need to know. Now, the difference between this one and this one is that this one has phase angle, but this one has frequency in it. So that's the difference between both of them. So this is the second one that you need to take note of. Then the last one which you need to take note of is this now. Which is this. Now, I have frequency here. I can just say that frequency equals 1 over period. Normally, that is our frequency. So for that, I can just say that my I is equals IO sine what's 2 pi, where I have f. I'll remove that f, and I'm going to place what? 1 over t. That is, my t is going to be here. 1 times this is going to be the same thing. Then I'll now place this my t beside it. So now this is the third one that you need to take note of. This is the third one. This is the third. The first one has phase angle in it. I'm just trying to point out a common feature that it has. Now the second one has what you call frequency, and the third one has what you call period. The first has phase angle, second one has frequency, and the third one has what? Period. So use the first one when you are solving phase angle, when you are giving phase angle, or you are looking for phase angle. Whenever you are asked or given anything related to frequency, you use this one, and use period whenever you are asked or given question related to period. Now remember that everything that I did for current can also be done for voltage. And I told you we cannot have current without voltage. So which means that if I write out of the voltage, it's going to be what? V is equals, what am I going to write? VO sine theta. That's the first one. What else am I going to write? The second one is going to be what? V is equals VO sine 2 pi ft. I'm only changing the i's and the i's that I have here to v's. So the last one is going to be what? V is equals VO sine 2 pi t over what? T. So these are known as instantaneous voltage, whereas these three are known as what? Instantaneous currents. Look at this question closely. How can I solve this question? This is a JAMB question, and you are given this question. This is a JAMB question, and you are given this question to solve. How can I solve this question? Let me read the question. The question says the voltage of domestic electric supply is represented by the equation V equals 311 sine 314.2 T. Determine the frequency of the AC supply. They never mention anything about instantaneous, but I can remember that there is a formula that I gave to you that ended with T. And what is that formula? Did you remember? There was a formula the last time that I told you that V is equals VO sine 2 pi ft. Yet, actually, there is another one that says 2 pi t over t. That is the second one that says V is equals VO sine 2 pi t over t. But out of these two, which of them am I going to choose? I'll choose this one. Why? Because I am asked to determine the frequency. Now, since I'm going to determine the frequency, they have given me the equation. And what is the equation? This is the equation that I know, but they gave me the equation actually from the question. And the equation says V is equals 311 sine 314.2 t. And that is it. I would like you to do some comparison. This is your V. And what is going to be your VO? Assuming they ask you your VO, automatically you know that your VO is what? 311. This is your sine. That is, this is equal to this. And automatically this 2 pi ft from the formula that I know that has frequency. That is the formula of instantaneous voltage that has frequency. I can compare with this one. That is, this one is equal to this one. So for me to solve this, I will just say 2 pi ft is equals what? 314.2 t. That's all I need to know. I can cancel my t and cancel my t. What do I have here now? I'll divide both sides by 2 pi. I'll divide both sides by 2 pi. When you cancel, what do you have here now? I'm going to have it as my f is equals 314.2 all over what? 2 times, what is my pi? My pi is 3.142. So my f is equals 314.2 divided by what? Okay, let me pick up my calculator. I have it as 2 times 3.142 will give me what now? Okay, I have it as 3.140. I have it as 6.284. So let's divide both. So I have it as 314.2 divided by this is going to give me what? The answer is going to give me 50. And remember to include your units, which is your what? 50 hertz. Consider the last part of the instantaneous value. I've considered the one that dealt with phase angle. I've considered the one that dealt with frequency. Now the next one we're going to talk about is the one that is going to be dealing with period. Now for the one that will be dealing with period, whether that of current or voltage, I'll just say that I is equal to IO sine 2 pi t over t. Now before you solve the one that has to do with period, please, you need to take note of this. Now, this is what you need to take note of. When your time is equal to your period, what is equal to be? I need you to know that your phase angle will be equal to 360 degree in terms of degree. This is in terms of degree. Then it's going to be equal to what? 2 pi in terms of what? Radian. In terms of radian. And it's still going to be equal to what? 1 cycle in terms of cycle. Okay? That is for this one. Then when your time is equal to period over 2, when the period is divided into 2, your phase angle will be what? 360 divided by 2, which is equal to 180 degree. And it's still equal to, this one is going to be what? 2 pi over 2, which is equal to pi radian. And the last one is going to be what now? 1 divided by 2, which is equal to 1 over 2 cycle. It's going to be half of a cycle. Okay. Now the next thing I'm going to say is this now. What if your time and you have your period divided by 4? So what do we have now? My first angle is going to be what now? 360 divided by 4. So which is equal to 90 degree. And which is the same thing as what? 2 pi. The same 2 pi divided by 4 is going to give me what now? Pi over 2. Okay. Now this is going to be what now? 1 divided by 4 is equal to give me 1 over 4. Okay, that's it. Then what if the time is equal to t over 8? My phase angle will be what now? 360 divided by what? 8, which is equal to 45 degree. Then it's still equal to what? 2 pi divided by 8, which is equal to pi over 4. Then this is the same thing as 1 divided by 8, which is equal to 1 over 8. See, it's 1 over 8. Now, I'd like you to take note of one thing, that when the period is divided by 8, in terms of angle, it's going to be 45 degrees. 45 degrees is something as pi over 4 radian, and you see the same thing as 1/8 of a cycle. So these three things, 1, 2, 3, 4, are the same thing. They are just telling you that in terms of period, 1/4 of a period, 1/4 of a period is equal to how many? Is equal to 90 degrees. That is 1/4 of a period is equal to 90 degrees, and that 90 degrees is something as pi over 2 radian, and that is something as 1/4 of a second. Half of a period is equal to what? 180 degrees, which is equal to pi radian, which is half of a cycle. And the same thing follows with the last one. Now, why am I even pointing out these things now? Now, normally, the question they will ask you using period, they may not give you the period directly. Rather, they might give you that the period, they might give you the period in terms of a period, or half of a period, or 1/4 of a period, or 1/8 of a period, or 1/16 of a period. You see the way it's going. After 1/6, 1/32, 1/32 of a period, and so on. So sometimes they will not give you the period directly. Rather, they will just give you in terms of one period, half of a period, 1/4 of a period, and so on. And when they give you that, now, you watch closely whether the answer ended, depending on the options they gave to you. If your answers ended with maybe degree, depending on the question, or in terms of radian, it depends on the question that you expected to answer. So let's see some questions under this to clarify how to use what instantaneous value that has period. Now let's look at the question. Looking at a question like this now, from what I explained to you last time, now let's look at how this is going to be solved. Now the question says that the instantaneous value of the induced EMF as a function of time is E equals E naught, that is a peak value E naught sine omega t, where your E naught is the peak value of the EMF, which is, we know that already. Now the instantaneous instantaneous value of EMF, 1/4 of the period. You see what I'm talking about? I told you that most times if you're given the period, they will not give you the period in terms of the exact value. Rather, they can just give you either one period, half of a period, 1/4 of a period, 1/8 of a period, and so on. So that is how they normally present the question. Now, what formula do you think we're going to use to solve this now? Remember, I'll just remember my formula. Which formula am I going to say? They've given the equation. I'll just say E is equal to EO. It doesn't really matter whether it's E or V. Just remember the step, which is you write the instantaneous value first, followed by the peak value or maximum value. Then you now write sine 2 pi small t all over what? T. This is the one that has period. So if assuming they made use of current, I'll just put your current IO. That's all you need to know. Okay, so now what am I going to say now? Since they said that it's 1/4, I'll just say that my t is equal to 1/4. That is 1/4, which is 1/4 of the, that is 1 over 4 times your period, so which is equal to t over 4, 1/4 of my period. So for that reason, what would I say? I'll just say that my E is equals what now? EO sine 2 pi over t times, what is now my t? My t now is going to be what? A t over 4. I'll say t over 4. That my small t is t over 4. I am showing you how to solve questions using period. First of all, you take out the small t and call it that to be equal to the quarter of, or the half of the period they gave to you. But this question, they gave you quarter of the period. So when you cancel this and cancel this, what do you have here? I have it as E is equals EO sine 2 pi over 4. Cancel this. What do you have here? We have E is equals to EO sine pi over 2. Now, did you remember when we were doing something about, before we started this calculation, what I told you about pi over 2? Take this video a little bit backward, a few minutes back. You will see where I wrote that pi over 2 is equal to how many degree now? 90 degrees. So I can just simply quickly say that my E is equal to EO. So it will just say that since we've known that my pi over 2 is 90 degrees, I'll just say that my E is equals to my E naught sine 90 degree. And what is sine 90 degree? My sine 90 degree in terms of special angle is equal to what? 1. So I'll just say E is equal to EO times 1. So E is equal to what? EO. And the correct option is what? This is my correct option. So that's it. Now, since you've understood the last one that I did, now I would like you to solve this question. Looking at the diagram that I have here, the diagram above illustrates the variation of the voltage V in an AC circuit with time t. If the peak voltage of the if the peak value of the voltage is 180 volts and t is the period, what is the instantaneous voltage as time t equals t over 8? Now you have this as the option. I would like you to try this one, solve this question, and drop your answer in the comment section. Next time, we're going to go in our next series. I'm going to be talking about what you call the peak value and root mean square. So I'm going to, in the next one, I will be talking about peak value and the root mean square. So if you are new to this channel, remember kindly to subscribe. Click on the notification bell icon to know when a new video is uploaded.